Hey guys, welcome back. Dynamic programming. I know this name does not seem familiar and also there is no clue in the name, right? When I was a kid, I learned multiplication tables, at least up to 20. Like 5 sevens are 35. I'm sure you might have also learned these in your elementary school. Why we still remember those tables? Because we use them so frequently in our life, almost daily, and we may not want to waste our time every time adding 5 7 times to get to know 5 sevens are, right? Just by remembering tables, can you guess how much time we saved in our life? Until you do that calculation, let me tell you, this is the basic idea behind this technique. While our code is going through some calculation, we can remember some of the stuff in between or some of the stuff from past so that we can save our time to recalculate. Thrilled? I know you are. This is a very famous technique that can solve most of the problems optimally. We will know more about dynamic programming. We will see how we can identify the problems for dynamic programming, and we will compare dynamic programming with few other approaches. We will know how we can approach the problems using dynamic programming. There are basically two approaches, top down and bottom up. And then we will solve some of the classical problems. This is very important section from interview perspective, so we will solve some extra problems in this. So in real life, if you're coding real systems, I'm sure you will be able to save some of your CPU time. Save the earth by writing better and less CPU consuming code. Ultimately, if you will write better code, less CPU will be consumed and less hardware will be required. So I'm sure this has been created some excitement to learn this technique. So let's start the real stuff from next lecture. See you there in the next lecture. Bye bye.